Okay, let's go over this one. Number two is a little bit tricky, so don't be super concerned if you didn't get it yet. We'll go through it. But let's look at just the first part here. We're looking for what is the vocabulary type. And I just will let you know that today's goal is to help prepare you guys for the mini test that we're going to have on Wednesday. We're done with chapter 10 after today. We're going to do a review, and then it's a really short test. Most of the points on the test is really vocabulary based. So hopefully you're going to really pay attention to what we're doing today. All right, what is the line segment? Now notice, it's a line because the arrow goes on forever. What is the line segment ED? Well, it touches point B at one point. Now, point B is called a point of tangency, so the line itself is considered a tangent line. All right, well, how about AE? Now, look at this is a ray, and it starts at A, and it goes all the way through E, and it goes through the circle at two spots. So if you just called this a secant, that would be acceptable. If you said secant line, technically it's a ray because it starts at one point and goes on forever, but I'm not too concerned about the word ray as long as you just call it a secant. All right, and then what is FA? Well, FA is this distance between the points. Now, it's not technically a secant if it stops at the circles. The secant has to go through the circle. So we just call this a chord. Okay? And I could have also asked you, what is AB? AB is a special kind of chord that goes through the center, and AB is considered the diameter, which we're actually going to need to kind of know for number two. All right, so let's look at this part right here. Number two, if BE is 6 and AE is 10, now here's the tricky spot. And this is why this is a little confusing. We know that a radius from C to B, and we know this is tangent, we know that that has to be 90 degrees. So there's my radius, but I want to go all the way from A to B, so I actually have two radii. If it's helpful, I would redraw this picture for number two. And I would say, okay, BE is 6, so that would be right here. AE is 10, and then this length, AB, is R plus R, or 2R. And then we can use Pythagorean Theorem. Hypotenuse is C. It doesn't matter which ones I call A or B then. So if I do Pythagorean Theorem, A or C squared has to equal A squared plus B squared. So 100. And then when I square this, I'm squaring both the 2 and the r. So this would be 4r squared plus 36. And then if you subtract, we minus 36 to both sides. That gives me 64. And then I have to divide by 4. And then I have to take the square root. So I end up with the radius. One of these radii is 4. And if they ask me to find AB, now notice they just said find the radius, so we're done. But if they ask me to find AB would be 8. All right, so those of you that said 4, you were right on. Those of you that said 8 actually gave me the diameter versus the radius. So that one was just it's kind of, think of it as an extension of the theorem that we learned before, where a tangent line and the radii form 90-degree angles. And we usually drew the line from the center to point E instead of from the diameter to E. Just a little extension. All right. I like this quote here. Darkness cannot be driven out, or darkness cannot drive. Darkness cannot drive out darkness. Only light can do that. Hate cannot drive out hate. Only love can do that. By Dr. Martin Luther King. All right. So this is a lot. You may want to take a screenshot of this. What I would like to do right now, and we're going to review some of these, and I believe that comes up in a little bit. So we have a test on Wednesday. It's only 25 points. It's usually half the value of a test we would do normally. And the reason why is we only spent a week and a half on this. And we had said almost half of these points are based off of vocabulary that you have to know. So what I'd like you to do is read through this list and just kind of maybe in your head think, okay, yep, I can identify what a circle is, what a center is, what a radius is. I know what a chord is. I know that a chord is a special kind of, a diameter is a special kind of chord. And then for the tangency, these two, the point of tangency is the spot at which it touches the circle. And then the tangent line is the line or ray that actually goes through or goes all the way touching the circle only once. A secant line is a line or a ray that goes through the circle twice. Right? So those were all our lengths or segments within a circle. And obviously I didn't draw all of these, but you should have those in your notes. And then we got into arcs, right? And one of the biggest things for this unit is the difference between a central angle and an inscribed angle. And we're going to focus on that a little bit today, but I'll just kind of draw the difference here. So a central angle is based off of your center point. Now, let's say that this central angle was 70 degrees. If that central angle is 70 degrees, then its arc is 70, right? And a minor arc is less than 180. So this green arc from these two endpoints would be considered a minor arc. A major arc is greater than 180. And then a semicircle is equal to 180. So I hope those are really, you're comfortable with those. If not, that should be something you go back and study. But what about the inscribed angle? Right, so let's say that I drew a picture like this. And let's use kind of that same picture as above. What if this was 70 degrees? Right, that's called the intercepted arc. If the intercepted arc is 70, then it's inscribed angle. An inscribed angle is when the vertex of the angle is on the circle. All we do is take that arc and cut it in half. All right, so know the difference between your central angles. Central angles are based off of the center. Inscribed angles are when the vertex is on the circle. All right, so that's all the vocabulary that we learned. Then we had a list of theorems. Now we're just going to kind of briefly talk about these. I'm a visual learner, so I might draw a picture for some of these. The tangent line is perpendicular to the radius at the point of tangency. That's technically what we just used to do the warm-up. So I could draw it like this, and we know that if this is truly a point of tangency, then this angle formed between the tangent line and the radius is 90 degrees, or perpendicular. Okay. The next one, we know that if I have a circle, two tangent segments from a common point outside of the circle are congruent. What that says is if I have two tangent lines, right, and they both have a point of tangency, so right here is a point of tangency and right here, and if they meet at a common point, then the length of this piece must be equal to the length of this piece. Now, algebraically, I could give you a problem like 10x minus 15 equals 5x plus 30, and you would set each of these lengths equal to each other. I just made that up. It should have a decent answer, but then we could find x. So that's this theorem. We already talked about this one. The measure of the arc of the measure of the arc is the measure of its intercepted central angle. I'm going to use the highlighter to match because we showed that right here. The central angle is the exact same thing as its arc. So that's the picture that would go along with this. All right, the intercepted arc, the measure of an inscribed angle, is 1/2 the measure of the intercepted arc, and that's the example we showed here. So you do have to know, what do we mean when we say the inscribed angle and the intercepted arc? And then kind of by association, the measure of an inscribed angle is 1/2 the measure of the central angle. So I didn't draw this picture, but if I put these two pictures together, that would show this theorem. So I'll do that over here really quick. So if I told you your central angle was 70, then you can conclude that its arc on the outside is also 70, right? But we also know that if I have an inscribed angle anywhere on the circle, let's put it right here, and it shares the same endpoints, then to find the measure of the inscribed angle, I take 1/2 of the intercepted arc or 1/2 of the central angle because those are the same, and that's where the 35 degrees came from. So it's kind of the combination of these two ideas put together. All right. And let's see. This one. Two inscribed angles with the same intercepted arc are congruent. So this was the idea that if I had this angle here, and let's say that this was 25, right? If that's 25, then we know its intercepted arc is 50. Nothing crazy there. But if I drew another angle in here, and the endpoints are the same, which means they share this same 50 degree, that means that this angle here has no other choice but to be 50 or 25 degrees, because two inscribed angles with the same intercepted arc are congruent. Okay. And then we've got an extension on that is an inscribed angle in a semicircle is always right. Okay. I don't need it that big. So let's just do this. If I take a semicircle, now I'm going to put a dot right in the middle to show that that is a diameter. And then if I draw in an inscribed angle, it doesn't matter where this point is. I believe we called it point P in the notes. Doesn't really matter. But notice its arc all the way around here is 180 degrees because that's a semicircle. So if its arc is 180, then this point has no other choice but to be a right angle. All right, and then the last one. And I will post these notes, so I'm going a little fast. I don't want you to write them. Let's say I take any 4 dots on a circle. It doesn't matter where they are. And I connect them with straight lines. What that forms is called an inscribed quadrilateral. So if I have the inscribed quadrilateral, then we know that opposite angles have to be supplementary. So I could call this x, and this is 100, and I could call this 70, and this one y, and you should be able to find x and y pretty quickly. We know that x plus 100 equals 180. So if I move 100 over, I get x equals 80, and we're in a good spot. And then if I do the same thing for y, 70 plus y has to equal 180. And then if I subtract 70, I get 110, and both of those would be degrees. Okay. So that's everything right there. We just covered it in about 10 minutes. Like I said, I will screenshot this, so if you need, or excuse me, I will post this out on Schoology if you need any help. You can always go back and refer to it. Okay, so before you guys do this, I want to show you what we're going to do. We're going to take about 15 minutes, and we're going to play a little Desmos activity. So you're going to go to a join code. I'll show you this in a second. And I'm just going to show you how this is played. So when you enter, you're going to have to wait for somebody. There is a time limit on the test. You're right. The test is 45 minutes. And the reason why is we want you to be able to know it without just going back and looking through your notes and spending all day on it. So test limit is 45 minutes, and that will be available Wednesday morning at like 5 a.m. So whenever you take it, but you have to take it before, I think it was 2 o'clock or so we can grade it and get it up to date. All right, so anyway, select a person, and then, so this is a practice round, and this is like, you guys ever play that game Guess Who, where you flip down the players and you could ask, okay, is your person wearing glasses? Or like here, it says, is your person wearing a long sleeve shirt? My person was. So then the computer I'm playing against is going to X out anybody with short sleeves. All right, now we're of the people left, is your person wearing glasses? My person is not. And so on. So you don't have to do this practice round, but now we narrow it down to 4 spots. Is your person wearing a striped shirt? So in this case, my answer is no. Is your person waving? No. And by process of elimination, they figured out who my person was. All right, so what you're going to do is you're going to wait for a partner, but we're not doing this with people. We're doing it with pictures on the graph. And unfortunately, I can't show it to you, but I wish I had a little screenshot of this. I don't. Let me just show you this quick. You're going to see a picture of a circle. So there's going to be, I think it's 16 circles. You're going to pick one, and it might be an angle, or it might be an arc. And you have to use your vocabulary knowledge from this unit. Let me see if I can show you. Okay, so let's say that I had this picture right here. Okay, it looked like this. What is that, right? And that's one thing that students you got to be aware of, is if you see a picture like this, it could be a minor arc, right? Because it's showing the red part on the graph that goes from here to here, which is definitely less than 180. So I may have picked an arc. Now, one of the questions, actually, I'm going to leave it up to you, because another picture could be like this. Right? So here, this shows a central angle. So what you really want to do is we're using the vocabulary from this unit to play a game like Guess Who. All right, and we're going to do it for about 15 minutes. What I'd like you to do is at 10:15, you may play this more than once, and what you have to do is every time you sign in, you're going to have to wait for a partner. Oh, here, somebody just signed in, it looks like. So see the different pictures? We've got arcs, we've got angles. You're going to pick them, and then you're going to use your vocabulary to do that. Okay, so what I'd like you to do is go to student.desmos.com and type in 2RJUYG, and then select the polygraph. It should be the kind of the only thing that's on there. You're going to select the polygraph option. I think I can get this out of the way. Maybe. And when you do that, you're just waiting for other people to join. You might have to wait because I think we have an even amount of people in class today. If we don't, you might have to wait until somebody joins. And I'd like you to just play this game a couple of times. All right? So let me know in the chat. This is my first time doing it with a group online. So if you are not able to figure things out, like you can't see it, you don't have it, then let me know, okay? And it might be slow. So you might have to have some patience with it. Okay, so let's go over this one. And I'm going to just set up my picture here. You probably already have this, but let's just start off with point A, B, and D are on the circle. And the arc AB, so if I pick B, now my picture might not be drawn super accurately, but I'm going to try to make it as accurate as possible. So AB and BD are congruent. And then the arc ABD is 208. So I'm going to say, well, halfway across would be 180. And if I go another 28 degrees or so, that would put D here, and then B should be somewhere in the middle. And if we know that the big arc is 208, but I do know that these two arcs are congruent, I don't know if it's good practice to put congruent markings or not. I always do. I don't know any reason why it wouldn't be accepted mathematically, but if the big arc is 208 and I divide that in half, that gives me the measure of each arc being 104. So notice really quick, just a connection to vocabulary. 104 is less than 180 degrees. So notice how we write that. AB, there's only two letters with the arc. That's considered a minor arc. But look at the way we wrote this one. ABD, that's greater than 180. So vocabulary-wise, that would be considered a major arc. And a lot of times you can tell by the way they write it using 3 pieces instead of 4, instead of 2. All right, so there's your first example. I would like you guys to try this one. It's up to you if you want to actually go ahead and draw this out, but I want you to find the value of x, y, jm, the arc jm, and the arc lk, and I'll give you a couple minutes to work on this. No, you don't have to. Somebody just asked, are we supposed to send it to you? No, I just want you to give a chance to practice it. So here's what we got. When I see a problem like this, the first thing that I notice is that I've got 4 inscribed angles, but if we connect those, that creates a quadrilateral. So I'm thinking anytime a quadrilateral is inscribed within a circle, the opposite angles have to be supplementary. So to find x, I know that x plus 123 is equal to 180. And then if I subtract that, I end up with 57 degrees. So x is 57. To find y, same logic, opposite angles have to be supplementary. So I'm going to do 180 minus 102. And I get 78 degrees. Okay. Now, the next thing is we want to find the measure of arc JM. So JM is from here to here. Now, that might not be super easy for us to do yet. But let me show you a couple things that we do know. I might as well highlight this one too. I want to find LK, which is this arc here. So let's see if I can do this without making a huge mess of my paper. Here's what I notice. Okay, X is 57 degrees. Right now, that's an inscribed angle. If I double that, that's going to give me the measure of the arc from J to L, right? So if I times 57 by 2, I get 114. But 55 of that is already taken up by the arc ML. So the measure of JM is 114 minus 55. So whatever that ends up being, 59 degrees. So this arc is 59 degrees. All right, and then we have to do the same logic here. But what I'm going to do is use the angle Y. So we know what Y is. Y is 78 degrees. And that's an inscribed angle. So if I extend Y all the way out, pretend that's a straight line, and I extend this length all the way out, we know the arc between those two is double the value of Y. See what I mean by creating a mess? So if Y is 78 degrees, and I double that, that's 156 degrees, all the way from here to here. Well, of that, M to L is 55 of that. So if I subtract 55, I get 101 for the green arc KL. So we're using the inscribed angles to kind of help us find the missing piece there. All right, we got two more. Oh, actually, you know what? We're going to skip that challenge one. We're going to do this. So here's what we got. Remember, your test is on Wednesday. All work for chapter 10 is due at 3 o'clock on Wednesday. You got to make sure that gets done. The test is 45 minutes. We want that in by 3 o'clock. And the reason why we say 3 o'clock is we have to update grades on Wednesdays. And I usually do that from 3:30 till 4 or 5 or 6, however long it takes. If you are interested, this is an optional assignment. You do not have to do it, but if you want to get more practice, here's some review problems that you could do for this chapter 10. The answers are posted on Schoology. Actually, I'm going to check that right now to see if I did post them. And I'll show you where they would be here. So if you go to our Schoology page, homework answers, chapter 10, I did not post them yet, but I will do that right now. I will post the optional review answers there if you'd like to do it. Okay, so here's what we got. We are 10 minutes away from class ending. I would like you guys to play one more round of the polygraph activity in Desmos. All right? So I should have unpaused it. Okay, it is unpaused now. And you can jump on and you should be able to find a partner and work through one more round. And then once you're done with that round, you are free to go. And I will be available from 1 to 2 on our office hour, at my office hours today. If you need any help, if you want help reviewing for the test, or you got further questions, reach out to me and let me know.